everyone, and welcome. Today, we're going to take a look at something you probably learned a long time ago and haven't thought much about since. We're going to explore this simple but surprisingly powerful act of squaring a number. So it all starts with a really basic question. What actually happens when you multiply a number by itself? I know, it sounds simple, but trust me, it holds a few surprises. With whole numbers, the answer seems totally obvious, right? 3 times 3 is 9. The number gets bigger, it's clean, it's satisfying, it's the math we're all comfortable with. This is our starting point. But what about when we leave that safe world of whole numbers? What happens if the number we're squaring is a fraction, something like 1/2? This is where our intuition can kind of play tricks on us, and honestly, where all the fun begins. Okay, so that brings us right to our first section, squaring rational numbers. Before we can really dig in, we need to quickly define what we're even talking about here. So what in the world is a rational number? Don't let the fancy name scare you. It's really just any number that you can write as a fraction, one whole number on top of another, as long as the bottom number isn't 0. So yeah, that includes stuff like 1/2 or 3/4, but it also includes a number like 5, because you can just write that as 5/1. And here's the best part. Squaring them is super easy. It's just 2 simple steps. First, you square the top number, the numerator. Then, you square the bottom number, the denominator. That's literally it. Let's see how it works. So let's take our example, 1/2. We square the top number, 1, which is, well, it's still 1. Then we square the bottom number, 2, and that gives us 4. So the result is 1/4. Now, just tuck that result away for a second, 1/4. All right, let's move on because this next part is where we uncover the really mind-bending part of all this. Seriously, this is where it gets interesting. Okay, this slide right here tells the whole story. On the left, you see what we all expect, right? You square a number bigger than 1, like 2, and of course it gets bigger. It becomes 4. But look at the right. When we square a number that's between 0 and 1, like our friend 1/2, it gets smaller. 1/2 becomes 1/4. That is the core surprise. And if you're a visual person, this chart just makes it crystal clear. Look at that first bar for 1/2. Now look at the bar for its square, 1/4. The squared value is literally half the size of the original. I mean, think about it. You're taking half of a half. You're taking a piece of an already small piece, so of course the result is going to be even smaller. So let's recap what we've just figured out. We've uncovered 3 really important rules. First, the square of a number is never going to be negative. Second, if your number is bigger than 1, its square gets larger. And third, the big one, if a positive number is less than 1, its square actually gets smaller. Okay, now that we've wrapped our heads around this kind of weird rule, how can we actually use this? Let's put together a little squaring toolkit with 2 key tools you're going to want to have. Your first tool is approximation. So before you even think about grabbing a calculator, you can use our new rule to just get a feel for the answer. You know now that if you square, say, 0.8, the answer absolutely has to be smaller than 0.8. It's all about building that gut feeling for what the answer should look like. And why is this so important? Well, because it's an amazing way to check your work. It's like having a little fact checker in your brain. If you square a number like 0.49 and your calculator spits out something bigger than 1, that intuition is going to scream, wait a minute, something's wrong here. And then, of course, for when you need that perfectly exact answer, your second tool is the trusty calculator. The real pro move is to use them together. Approximate first so you know the neighborhood your answer should be in, and then use the calculator to find the exact address. And behind all of this is this really cool, comforting idea in math called the existence theorem. We don't need to get into the weeds on it, but it basically promises us that a correct answer is always out there waiting to be found. It's a guarantee that we're not chasing something impossible. Pretty neat, right? All right, let's bring it all home and go beyond the square to nail down our journey's biggest discovery. What's the one thing you should really walk away with today? It's this, right here. The big takeaway is that squaring is not just a make it bigger operation. It's way more interesting than that. It can make numbers bigger or smaller. It all just depends on where you start. Are you bigger than 1, or are you one of those little fractions between 0 and 1? And that leaves us with one last really juicy question to think about. If this is what squaring looks like, what about unsquaring a number? If squaring a tiny fraction makes it even tinier, what do you think happens when you do the opposite? But that's a story for another time. Thanks for hanging out with me.